today we're going to talk about continuity and determine if something is continuous. And then just talk about what being continuous means. So you don't really need to write this down. If something is continuous, it means almost what it normally means in everyday life. What do you think when you hear something's continuous? What do you think that means? Keeps going, doesn't stop, right? It is pretty much the same thing with functions. Now, this is not a good formal definition, but if it's continuous at a point, it just means that the graph keeps going. It doesn't have a break in the graph. There's no holes. There's no asymptotes. There's no jumps. It just keeps going. Or another thing you could think of is if you're drawing a function and it's continuous at that point, then you don't lift up your pencil. Okay, so as you draw something, if it's continuous, you're just not lifting up your pencil at all. So some pictures to go with that of when things are not continuous would be if it has a hole. So you might want to just write down not continuous and just maybe draw an example of it. So if it has a hole, not continuous. And that would be that the function's not defined there, right? It would be a hole. Or over here you can't see it very good. It might kind of pain to get to. The other one that I have over here is if at C you have an asymptote, so it's undefined at C because of an asymptote, then that is also a place where it is not continuous. Okay, because I would have to draw one half of the graph, then the other half. But that would also be f of C is not defined for both of these. So this one, we should probably specify that it would be a vertical asymptote. So today you're going to have to say things like the function's not continuous at C, the reason there's a hole there. Or it's not continuous at C because there is a vertical asymptote there. Or this one, kind of the more technical definition of it would be, it's not continuous at C because the limit as x approaches C does not exist. So from the left it equals this point, the limit from the right equals this number. But today you don't have to say the limit of f of x as x approaches C does not exist. Today you can just say, if you want, that it jumps. Okay? So the reason it's not continuous is because it jumps through another point. And this one is kind of like the first one, except for it is defined at C. It's just down here. This one is saying that the limit as you approach C from both sides, it just does not equal the same thing as the function value. Okay? On that one, it's actually called point discontinuity, but really you don't have to really know that. Just know most of the ones you have to do today, when you have to say why it is discontinuous, you won't have to say that. We do need to talk about, so kind of ignore the rest of this stuff down here. But you need to be able to say if it's removable or not. And you don't have to say that on your homework. Let's just talk about whether it's removable or not. Yeah.
So what would you say in the answer for C?
So the ones that you have to do where it says, where is it not continuous, you would just say at C. And there are actually none on the ones you're doing that are like that. It has a different point value on it. So to decide if it's removable or not, you just look at it. If you could either redefine the function value at C or define it at C, like this one, if I define the function value at C to be that point and it filled in the hole, then the function would be continuous. So this one is a removable discontinuity because all I need to do is reassign that value to be that. Or not reassign it, it just needs to be assigned that because we didn't have one. This one, no matter what you make f of c be, no matter what y coordinate you try to do, these will never match up. So this one is non-removable. And this one is removable. Because all if I could redefine that to be up there, then it would be removable. What about if I had an asymptote? Is there anything I could do to change this one to make it so that it was continuous, so that I didn't lift up my pencil? No. So this one would be non-removable.
Wait, so the other one where the point is elsewhere, that's it's removable discontinuity because we just have to move that point? Or?
Yep. So pretty much this, if you look at it, if the limit as x approaches c of f of x, if it exists as a number, not as like positive infinity, but if it exists as a number, then it is removable. Well, I knew I could actually. Okay, so look at this as you approach this from this side. You get really close to this. So the limit as you approach C is that value right there. But on this one, the limit is different from the left and right. On this one, even if they both went up and it was positive infinity, you still couldn't hook them together. And remember, it really doesn't exist. Yeah.
So it's removable if it's continuous on the whole rest of the function outside that one point.
Yeah. And really, for right now, something else could be going on over here and over here. But for right now, just on this part that we're looking at, we're only looking between here and here. So between here and here, if the only place you have to lift your pencil is right there, and if you could just change that one value, and then you could just keep going, then it would be. Yeah.
So what is it called?
Just because, could you redefine it and make it continuous? If you redefine that one point, could you make it continuous? Is there something you could make it be to make it so you didn't lift up your pencil? So right here.
Like if you could remove the whole,
Then it would now be continuous.
and then if you couldn't remove the whole, and then it would.
Yeah, because this one, no matter what I do, I have to pick up my pencil, move down here. But this one, if I could just make that be something else, then it'd be good. This one, if I could make it be something else, that'd be good. So, if I want to say, what does it mean to be continuous? Like, give it a definition. This, and this have to happen, then it's continuous. So I kind of told you what happens to make it not continuous. But the definition of continuous, when you plug in C, if it's continuous at C, then you know that when you plug it in, it has to have a value that comes out. You can't have a hole, you can't have an asymptote. If it's continuous, when you plug in C, you get a value. Okay? No holes or asymptotes. Also, the limit, as you get close to C, it needs to exist. And that limit needs to be the same as the value. So that's kind of the three things. Or, another way you could think of it, the limit from the right and the limit from the left, because that has to be, the limit exists, it has to be the same from the right and the left, and it has to equal the function value. So no matter what, if I have a value C and it's continuous at C, that point has to exist. It has to approach that from the left, and it has to approach it from the right. Yeah.
Is there an example of this where it wouldn't be very obvious visually?
Sometimes your calculator can play tricks on you, but if you had the correct graph, it would be obvious. Questions off your homework? So on this, we're actually, if we want to think of the graph, we can, but mostly we just need to write down the answer. So if I were you, since 1 through 15, so you don't have to explain what you're doing when you go back and look at it, I would write down And if you're doing this in your notes, you can write whatever, but if you're, don't care if your homework's mixed up, I don't care if it's mixed up. Or you can write it in your notes and put it in your homework. But number one really is number one in your homework. So, on your homework, kind of write the instructions out on the homework so you know what you're doing and you don't have to answer each question in a complete sentence. Yeah.
You're allowed to write the homework then?
No. That's what I'm saying. So you write the instructions to the homework in your composition book. So in your composition book, make sure you label your homework, homework number 3, and write down, you can even just write down, yeah, you can just start your homework if you want on your composition book. Might not be clear?
Yes.
Okay. So where, well, I don't know, you can either write it exactly how it looks or you can try to make it shorter if you want. So find all values of x where the function is not continuous, whatever you want to write. And then it also says identify the type of discontinuity. So if you only write that once, then you don't have to sit there and write it a ton of times. And if you go back later, you'll be able to see what you were doing. So next in your homework, I would want you to write the function out. So write number 1, make sure you write the function out. Really, all you're looking for is either holes, asymptotes, or jumps. And you should be able to see them from your function. So if you write this function down, I would then factor it, right? And all you have to do for your answer is say, where is it not continuous? So what x values cause the problems in this function? Nothing simplifying, right? So where is it not continuous at? X equals -3 and x equals 2. Are they holes, vertical asymptotes, or does it jump at those values? Yeah, they both are vertical asymptotes, so you can just write vertical asymptotes. Because the only ones that would be holes would be if you had x plus 3 on the top and x plus 3 on the bottom. Then this one would have a hole at x equals -3 because it had common factors. So if it has common factors, those are the holes. Other than that, if you put it in and it makes you divide by 0, it's an asymptote. Yep, so the answer is x equals -3, x equals 2, vertical asymptotes. So as I look at this one, number 10, so this is not in order, sorry, I wanted to do this one.
Do we still have to do the total this?
I did, it was a vertical asymptote.
No.
So that, all I'm asking you to write on those is just,
Oh, okay.
is it a hole, a jump, or vertical asymptote?
Okay.
I mean, really, we could say f of c is not defined, f of 3 and f of -3 and f of 2 are not defined, but the reason they're not defined is because we're asymptotes. Okay, this one, obviously the first answer where it's not defined, I can't divide by 0, so I know it's x equals -2, but you've just now got to decide, is it a vertical asymptote or not? So it might be, it might not be. You got to factor and see, right? Or if I plug it into the top, I get 0. If I plug it into the bottom, I get 0. It's probably a vertical asymptote, but maybe there's still, well, not a vertical asymptote, it's probably a hole. In fact, it kind of has to be a hole because there's only one thing on the bottom. So you can almost just tell from that by plugging it in, you know it's a factor of the top, a factor of the bottom. There's got to be that factor up there. This is the only thing left on the bottom. It's got to be a hole. But if I factor it, this is the one we factored before. So the top becomes x plus 2, x plus 1. Since it simplifies down, there's a hole there. So you just write hole. Now if I wanted to know where the hole was, I'd have to plug in -2 to find out where the hole was. But it doesn't ask that. You just have to say, it's not continuous here, it's a hole. Okay. This one up here I have written C. It is not on your homework, so this one is just for your notes. Where is this not continuous? So you're checking, it's a line and a parabola. They're both continuous. If it's not continuous, what are you thinking to check for? Where might it not be continuous? It might jump, right? Maybe at 0 it jumps. You gotta see. So if I plug in 0 into the top, it is at 1. And it is a filled in one, right? Because it actually is less than or equal to. So if it didn't have the equal to right here, you would say it was not continuous at 0, because it wouldn't be defined. If it actually is defined at 0, it's 1. It approaches that from the left side. And when I plug it into this side, or to this one, I get 1. So they lined up, they hit the same point, the same y value. So is there a jump in this one? Yeah, it just, and really if you looked at this side has a hole in it. It goes from here and then up. But as I look at the top one, it fills in the hole and then it is a line. So that's what the graph looks like. It's continuous the whole time. So this one, so maybe a good question that you had to write something out about. This is continuous. Where is it continuous? Continuous at all real numbers. But if I had to explain that, how would you explain that it was continuous? You'd have to kind of know the definition of continuous. So what was our definition? What part was something in it?
That the limit is equal to the actual value.
Okay, so the limit as x approaches 0 of h of x equals h of 0. Okay, so it has to be the whole limit as you go from the left side and the right side. It has to equal h of 0. So probably if I was doing the AP exam, I would write, it is continuous because limit as this approaches this equals 0. I'd like write it as a sentence instead of just writing it. Yeah, right now, all you had to do is say this. But this is why, if I made you explain why. Because of the definition, it meets all the definitions of it. The limit exists, h of 0 exists, and the limit equals h of 0. Well, yeah. And maybe that would maybe be the other part. We wrote these, but maybe we should make sure we write the limit exists, the function value exists at 0, and they are equal. Yeah.
So if we have discontinuity, we would say discontinuity at this point, or would we say it's continuous here and here, but not here?
Usually you just say where it's not.
Okay.
I mean, if some of them, if it happens to be maybe something that's not all over all real numbers, and it maybe it's like a circle, half a circle that goes like this. I don't know if that was it really. Say the function was this, then you could say it's continuous from here to here, but the not continuous here. But yeah. As you look at 3, where are you thinking it might not be continuous? Because as you look at it, a parabola is always continuous. X equals 2, or sorry, y equals 2, a horizontal line is, and this line separately, if it was all real numbers, they would be continuous. So obviously you're just looking at 3. You guys get that? That's the only thing that we might look at. So on this one, what does it equal? 2. So we know that it's right here. Everything less than 3, it equals this. So I need to plug in 3 to see where it's at. So 3 squared minus 2, 7. So it's this parabola everywhere to the left of 3. So up here at 7, it's an open circle, then it comes down, comes back up, looks like that. Right there I can say it's not continuous, right? Because these two are not the same value. Let's just double check what this was just for fun. If I plug in 3 right here, then I get 7. So right here, it looks like that. So this is one of those that has just the one point that's off. If I could redefine this and make that be 7, then it would be continuous. Yeah.
How did you get 7 and make it go all the way down to 8?
Oh, I just knew that the parabola, I knew what this parabola looked like. I knew that the parabola went down here and looked like that. So I knew it had to be a parabola that looked like that. So I just stopped it right there. So I knew that it was up here, and I just knew because of the shape of this parabola, the x squared one shifted down too, that I just went down like that. And it really didn't matter where it went. It just was a parabola, but I graphed it the right way. Yeah. Would you call it a jump? I don't know. I'd maybe call it a hole. But it says in the back it's a jump, huh?
Wait, isn't it like officially called point discontinuity?
Okay, so that makes sense. So the thing is like, I read 2 different books. This is what I was telling Hannah. I read 2 different books, and they called them so many different things. And they were talking about, so the main thing you would have to do on the AP exam is not, you just have to be able to say it's not continuous at 3. But yeah, this one, if you had to say what kind it is, it's x equals 3, is where it's not continuous. And yeah, that makes sense, that if you're coming here, and then you have to jump down and then jump back up, that it was a jump, because you had to leave and jump. So this one, jump. But the kind of thing you would see on the AP exam would look more like this. It would have the function, and it would have, and this is what we're going to talk about next, it would say more something like, what values of A do I need to, what does the value of A need to be in order to make this be continuous? So instead of making it be not continuous and having it, or if it would say that, it would say, is it continuous? No. Or it would say, what value do I need to make A in order for this function to be continuous? A would have to be what in order for this to be continuous? 7 to be continuous. So kind of as a totally different problem.
But the x needs to be squared.
Oh yeah, thank you.
I was thinking that's not going to be continuous anyway.
So what do you divide it?
On the, so this would be a good AP question, maybe not a good short answer one, maybe a good something to do with multiple choice. So if I have these functions, so when you write it down, I want you to write down the function, and then you'll probably figure out that you're trying to make it continuous. You need to make all of these functions continuous. So maybe just right after you get done with 15, you go to 16, right? What values of A and B will make it continuous? The rest will be that question for a while, up to something. So you've just got to be thinking as you look at these, where do I know it is for sure? Like on this, I don't know where this is, because I don't know what B is. I don't know where this is, because I don't know where A is. But right here, I know where this is. It is this parabola everywhere from 2 and below. So up until I hit 2, it's continuous all the way until I hit 2. So I'm good up until 2. But from 2 to 4, I'm not sure what's going on. From 4 up, I don't know yet. So what do you think you need to do first? Do I want to solve for A or B first on this one? A, yeah, because I need to know where this is before I can know where this is. So up here, I'm going to plug in 2. And when you plug in 2, you get 9. So I know that this one is at the point 2, 9. So I need to make sure that this one starts at the point 2, 9. So how am I going to make sure that this one starts at the point 2, 9? Yeah, you plug in 2. So this one's a little bit different. You're not always plugging in for the x and solving for things. Oftentimes you're solving for x, but on this, I know that at 2, I need to plug in x. I get 2 squared plus something. What does that need to equal? 9. I just figured out above that it needed to equal 9. So now you can just subtract that, and you know that your A is 5. Okay, so now I know that it matches up at 2.
So why did you put in 2?
I plugged in 2 because that's the left side of this one, and I need to know where it's at. But I don't know what the A is, but I know it has to match up with that side. So I know this parabola right here.
Oh, because you have less than or equal to 2 and
2 to 4, yep. So from 2, and then here's 2 to 4. So it's now continuous at 2. What's the other place that might not be continuous? 4. I need to find out what it's doing at 4, right? Do I know what this function is doing at 4? Now I do, because it's going to turn to a 5. So right here, when I plug in 4, I get 4 squared plus 5. 21. So I know that that one ends at the point 421. So I have this parabola, then I have this parabola, it goes up to 421. And now I have this line, and it's going to be that line for the rest of the time. But what does B need to be in order for it to match up at that point? Some of you guys will get it fast, some of you might take longer, so don't worry if it does, because it's going to be what? What do you need to do? I know what, do I know what the x coordinate is? Yeah, 4. Do I know what the b is? No, so I know that b times 4 plus 9, do I know what that has to equal once I plug in 4? It has to equal 21 when I plug it in. So now I can find out what b is. Subtract 9 and divide, so b must be 3. So a is 5, b is 3. Okay, what questions on this? Yes, no, Stephanie? Good? Oh, without figuring out? Yeah. Okay, so for right now, I want you guys to all take just a second. I want everyone to work on 17 right now and see if you get the right answer. So don't look at the answer. And as you look at it, notice this one has an A in it. This one has a B in it. This one doesn't have anything in it. You know what's happening right here. Everywhere between 2 and 4, it equals this function. So you can find out those endpoints and try to make the other endpoints match to it so that it lines up. So on this, you guys all realize that you have to plug in 2 and 4, right? Because those are the ones you know, 2 and 4. So at 2, this function equals 18, and at 4, this function equals 30. So you just need to double check and make sure that you make, when you plug in 2 to this one, this needs to equal 18, and when you plug in 4 to this one, it has to equal 30. But you're plugging in 2 for x right here, and in this one you're plugging in 4 for x, and then finding what the a and b need to be to give you 18 and 30. Everyone look at number 20 quick. This one says f of x equals x squared minus 9, x plus 3. X cannot equal. What can x not equal? Here's a, but what does a have to be? That's going to be a problem. Yeah, so you know that a equals -3. Now you know down here that when x equals -3, you have to figure out what b is going to be. But hopefully when you look at this, you see that this is a common factor, right? So if you factor it, what is happening at 3 for this function? There's a hole. Yeah, because I have this right here. There's a hole at 3. So I need to fill in the hole. You need to find the value that's going to fill in the hole. So it really is just this line with the hole. What value does this y value need to be in order to fill in the hole? So depending on what it was, this one happened to be x minus 3. It won't always be like this. But if I plug in 3 or -3, did I plug it in right? Yeah. Is that looking right? When you plug in -3, the b value equals -6. Am I doing it right? Last period I did it wrong. So when x equals -3, you plug it in and see what you get, and it happens to be, b would have to be -6. Yeah.
So is B the points that would fix it?
Yeah, b is the y coordinate that will fix the hole.
So the x doesn't equal A, so it's saying there's a hole there, and then x equals A, it's saying that that's where the hole is going, fixing the hole.
Yep, so here's the hole, here's fixing the hole. So this is the x coordinate of the hole, this is the y coordinate of the hole. So that's the y coordinate of the hole.
Oh, okay, that makes sense.
Yeah, so when I plug in 3, this is the y coordinate I get.